Hi students, as a part of nanotechnology, in fact, as a part of one of the topic which is related to the nanotechnology, that is photolithography, today I'm going to explain about experimental procedure for designing the pattern on silicon using photolithography. So before going to enter into this particular video, I want to make one thing clear to you that so many terms are involved in this particular video. And whatever the term, each and every term which is involved in this particular video, about these terms have been explained clearly in the previous video which I have made on photolithography. So, in order to understand this particular video, so definitely you have to know the definition of each and every term which is a part of that particular video. So in this video, I'm not going to explain, I'm not going to define those terms. Instead, I will utter those words, but I will not define those words. So, before watching this particular video, my sincere request to you that please do watch that video which have made on photolithography before watching this particular video. The link of that particular video is provided in the description. Now, without wasting much time, let us enter into this particular experimental procedure for designing the pattern on silicon using photolithography. And for any of the experimental procedure, we require the chemicals and the equipments. So before going to discuss about the experimental procedure, we have to know what are the chemicals, what are the equipments required for this particular experiment, and what is the role or purpose of each and every chemical and equipment which is required for this particular experiment. Accordingly, first, I will discuss about the chemicals required. So mainly 6 chemicals are required for this particular experiment. The first one is silicon, followed by acetone, and third one is the combination of novolac, which is the bakelite polymer, and diazonaphthaquinone. And the fourth chemical is tetramethyl ammonium hydroxide and tetrabutyl ammonium hydroxide. Fifth one is ferric chloride. And the sixth chemical is hydrochloric acid. Along with this, even the water molecules, water is also required as one of the chemicals, but I have not mentioned or not specified or not depicted in this particular slide because the water is the universal solvent. There is no need to mention that particular chemical. But these are the chemicals which are basically used in this particular experiment. Now let us see the purpose of each and every experiment. Right. So let us start with the first one, silicon. Silicon here is the substrate, students. And what is a substrate? Already I have discussed that. I'm going to utter the substances which are being used, but I'm not going to define what are those substances. What is the definition of that particular substance? Please do watch that video, students. Otherwise, you won't understand anything in whatever I'm going to explain in this particular video. So first, silicon is a substrate, students. So coming to the second chemical, that is acetone. Acetone is the silicon purifier. the silicon may contain some of the impurities on it. So before processing or during the experimental procedure, the first and foremost thing what we need to do on the silicon is we have to wipe out, we have to remove all the impurities which have been accumulated on the surface of the silicon substrate. So for which we have to use the purifying agent, which is the acetone. So coming to the third chemical, which is a combination of novolac and diazonaphthaquinone. So novolac is the linear polymer of the bakelite. Bakelite is the cross-linked polymer and novolac is the linear polymer of it. So this combination is used as photoresist. So this is another term. What is photoresist? Also I have clearly explained in that particular video. Photoresist. Next, the combination of these two, tetramethyl ammonium hydroxide and tetrabutyl ammonium hydroxide, is used as developer. This particular combination is used as developer. Right. Next, coming to the next chemical, ferric chloride, followed by hydrochloric acid, even the water. The combination of three is used as the etching solution, and etching solution is being used for etching operation. And what is etching operation and what for this particular etching solution is being used, which is the combination of ferric chloride, hydrochloric acid and the water, you're going to know, you are going to understand during the experimental procedure. So this is about the chemicals which are required and the role or the purpose of each and every chemical which is a part of this particular experiment. So now let us talk about the equipments and the role of each and every equipment which is required for this particular experiment. This particular experiment require 4 major equipment. I'm not saying that only these are the equipments required, but 4 major equipments are required for this particular experiment. The first one is spin coating machine, second one is UV lamp, the third one is AutoCAD software, and fourth one is mask. So first, what is the role of the spin coating machine? Spin coating machine ensures the uniform layer of photoresist on the surface of the substrate. For ensuring the uniform layer of photoresist on the surface of the substrate during the experimental procedure, this particular spin coating machine is used. So coming to the second equipment. UV stands for ultraviolet lamp. Ultraviolet lamp, obviously, the name suggests that it is a source of ultraviolet radiation. Now, what is the purpose of ultraviolet radiation in photolithography? I have clearly explained in the previous video. Please do watch that video, students. So coming to the third equipment, which is AutoCAD software. So what is this software about? The software allows us to draw 2D and 3D designs. That is basically this software in this particular photolithography is used to design the pattern. So design the pattern, this AutoCAD is being used. And the last but not the least, the very important equipment which is being used in this particular photolithography is mask. Now, just I will try to define the mask. It is an opaque plate or film with transparent areas that allow light to shine through in a defined pattern. This is the mask. So already I've explained in the previous, but I'm throwing some light on the mask again, right? So we have discussed, we are done with the chemicals and the equipments required and the role of each and every chemical and the equipment required for this particular experiment. The now is left. The leftover part is experimental procedure. That is, what is the protocol which is to be followed in order to design the pattern on our substrate, which is the silicon, right? So let us go with the experimental procedure. The first and foremost step in this particular experiment or design of pattern on the surface of the silicon substrate is design pattern using AutoCAD. So making use of AutoCAD, I already have explained what is the role of AutoCAD software, what is the purpose of AutoCAD software. So making use of AutoCAD software, we have to design the pattern which we want to give to our silicon substrate. So based upon the desired pattern, we can choose any of the pattern making use of the AutoCAD. Right? So already we are well versed with the previous video that this particular silicon, which is a substrate in this particular case, is exclusively used for making the integrated circuits, right? And in the integrated circuit, if you see the pattern on the integrated circuit is very complex, right? And one will be in one fashion and another will be in another pattern, another will be in another pattern, right? So whatever the pattern we want to give for our silicon, which is going to become one layer on the integrated circuit, accordingly we can design that pattern using AutoCAD. So this is the first step. Coming to the second step, prepare the mask by printing pattern on it. So we have to prepare the mask by printing pattern on it. This is the second step. So coming to the third step, I would like to take some time to describe this particular step, which is very important. So what we need to do in the third step is we have to take the substrate, right? And we have to ensure that there is no impurity and oxide layer on the surface of the substrate. Otherwise, what happens is, so we have the mask with the designed pattern, right? Design pattern. We have the mask, and this mask with design pattern should be developed on the surface of the substrate. But if the substrate surface, that is silicon surface, is not free of the impurities and oxide layer, this mask with design pattern will not develop properly, that is, will not sit properly on the surface of our substrate, which is silicon, for which we need to wipe out all the impurities and all the oxide content which is present on the surface of the silicon substrate. So in order to remove the impurities from the surface of the silicon substrate and oxide layer from the surface of the silicon substrate, what we need to do is we have to do the two operations, students. First, we have to rinse the silicon substrate with acetone. When we rinse the silicon substrate with acetone, all the impurities which are accumulated on the surface of the silicon will wipe out. Next, what is left? We have to wipe out even oxide layer. We have to remove even oxide layer in order to facilitate the good bonding, good development of the mask with design pattern on the surface of the silicon substrate. You have to remove the oxide layer, for which we have to rinse the silicon substrate, which is free of the impurities after rinsing by acetone with dilute HCl. When we rinse with the dilute HCl, then whatever the oxide layer which is present on the surface of the silicon substrate is wiped out. Now our substrate is pure. It is free of all the impurities. It is free of oxide layer, all that nonsense, which will become the obstacle, which will become the hurdle for the proper development of mask onto the surface of the substrate. Next, what we need to do. Substrate which is free of the impurities, on this we have to pour the photoresist. So I'm saying pour. That means that it indicates that the photoresist is liquid. Yes, students, the photoresist is liquid. So we have to pour the photoresist on the surface of our pure silicon substrate. After pouring the photoresist, liquid photoresist on the surface of the silicon substrate, then we have to place this combination of photoresist and the substrate silicon in one of the equipment out of the 4 we have discussed earlier. That is, we have to place in spin coating machine. And what is the role of a spin coating machine? I have clearly explained. Once again, I will. What it will do, students? It will ensure the uniform coating of photoresist on the surface of the substrate, on the surface of the silicon. Right? Now, the layer of photoresist has been formed on the surface of the substrate, that is silicon. Now, what we need to do? In the next step, we have to expose the substrate. So don't forget, student, our substrate is not free of photoresist. Photoresist is there. That should be exposed under ultraviolet radiation for 10 minutes. Ultraviolet radiation for 10 minutes. Now, whenever the substrate comprised of photoresist molecules, just forget about the photoresist molecules now. Now, the substrate is present. Now, this substrate is placed in the UV chamber for 10 minutes. Now, what happens is the mask containing the desired pattern will project on the surface of the substrate. I hope you're getting. When the mask will project, it will not develop. It will only project on the surface of the substrate. Now what we need to do, students? It has been projected, but it has not been developed. So what we need to do? There is a need to develop the desired pattern containing mask on the surface of the substrate, which is the silicon, for which you have to dump the substrate in developer solution for 2 minutes. So now, dear students, whatever the mask which was projected earlier will be developed on the surface of our silicon substrate. Now, it seems that our job is finished. Because our intention was to design a pattern on the surface of the silicon substrate. Now, it has been developed on the surface of the silicon substrate. Now, dear students, just think, does our job is finished with this? No, it is not finished. Yet to be done something. No doubt that the pattern has been developed on the surface of the substrate silicon, but the photoresist molecules are there on the surface of our product. So there is a need to isolate our product individually. What is the product? Desired pattern containing silicon, right? So that we got, but we got along with the photoresist molecules. So we need to wipe out, we need to etch out those photoresist molecules, for which the next operation to be done is etching process. Now, whatever the product which is obtained along with the photoresist should be dumped into the solution, which is a combination of water, iron chloride, and 2 to 3 drops of hydrochloric acid as well. Now, under the influence of these three chemicals, water, ferric chloride, and the hydrochloric acid, what happens is whatever the photoresist which was there now gets wiped out. Now, photoresist was there earlier. Now, with the help of this etching operation, making use of the etching solution, which is the combination of the three chemicals, water, iron chloride, and the HCl, we have made our product free of photoresist. So finally, what we need to do, the job is done. So wash the product with the water and isolate individually, and wherever we want, whenever we want, we can use that particular silicon. In fact, the patterned silicon, right? So I hope you understood this particular experimental procedure, students. So thanks for watching. So keep watching. Please comment on the video so that I can know to how much extent my lecture is reaching to you. So thanks once again. Bye. Take care.